Perfect. So we are now live. Cool. Well, thanks for coming in after your long weekend, everyone. So there's a few, we can go around and do sort of quick updates, quick reports. If anyone has the notes open, please feel free to add yourself to the list of folks who are attending. One of the things actually, and this would be, I think, a good habit for us to try and start doing is actually like everyone, just list your name if you are attending versus not. One of the things that it's been kind of interesting, just keeping in touch with the Pangeo project, they've had to work with the NSF just to show like that they are making progress and stuff like that. And simply just having meeting notes with like who showed up was actually a huge step there. So it's kind of a low bar, but a nice thing for us to keep track of. Cool. So I have a couple quick updates, but maybe we can go around first, and if there's anyone else who wants to start us off, go for it. So maybe I'll go by the order on my screen. John, do you have any quick updates you'd like to share before we'll go into MT longer, but feel free to give a quick summary if you like. Oh, you are muted.
There we go. Okay. Yeah, it's just still working on DC, Gradiometry, and MT. Still just trying to make the parallelization a little bit better. Yeah, trying to look better.
Any progress?
A little bit. I found out maybe some other avenues to explore, but yeah, I'll probably go into more detail here at the end of the talk here, or the.
Perfect. Thanks, John. Joe, do you have any updates or things you'd like to share?
Yeah, sure. You guys hear me okay?
Yeah.
Okay. Over the last week, I had a thought on the volume averaging operation, and I implemented something pretty quickly in Python to test it out. So I think I've got a nice way to work to have that implemented. And that's extensible for 1D, 2D, and 3D, at least for the tensor meshes for now. But I think I have a good understanding of what's happening there. So it should be a quick addition if we want that.
Excellent. That'll be really helpful.
Yeah, Joe, if you need a beta tester, I'm happy to.
Yeah, I sent some of the test stuff to Dieter.
Oh.
So he was like running it through. Correct. So it seemed to check on his end.
Excellent.
Joe, can you average volume like I think he was using, like, he needed something like a center to edges. Is that correct?
It might have been. I was trying to look at how it was implemented there. I kind of got an idea of what was happening really quickly and implemented my own way of doing it without really looking what was happening there. But essentially, I was just looking for overlapping cells in each dimension. So along one dimension, I look for the overlapping cells, and then go from one to the other.
Okay.
So you just essentially need the nodes along each dimension for a tensor mesh.
Oh, I see. Got it. Okay.
Excellent. Thanks, Joe. What about UBC? Anyone have updates there?
I can start at the end of this end of the table. I'm keeping track. I answered a few questions on the Google group forum. One that came up is that I guess what's on GeoSci.xyz computations, we haven't updated the notebooks. So I did the update for the Mac, but I created an issue on the computation repo, but we would need to review all those examples because they're breaking. They're not matching master.
So
yeah.
There's also DC. There's an MT example. Is that correct?
Let me go back 1 second.
Because one of the things I'm wondering,
Yeah.
we can think about this. This is just off the top of my head, but I'd appreciate thoughts. Do we want to maintain this as a standalone thing, or do we want to incorporate these into the SimPEG examples? Does anyone have gut reactions to that?
I think it would be easier, right, if it's under the same umbrella. We're not testing notebooks, are we, even on SimPEG?
No, we don't have notebooks in the SimPEG repo. So I guess like the thing would be here to rewrite these as like Python scripts that then are compiled with Sphinx Gallery to notebooks.
It's probably while we have to re-update all of them, that's probably a good idea. It'll be easier to maintain.
Okay.
How many is there? So I have the repo here. Notebooks, fundamentals.
Is this like the TKC ones, or?
It was.
Yeah. Is it GeoSci.xyz computation? Is that correct?
Under docs, and then there are case studies, and then you have a DCIP, and I guess I should share my screen then.
Oh, I see. Oh.
Right, we have these guys here.
Oh, I see.
I guess that's what we had done for geoscience for BCGS when we did our presentation.
Yeah.
Yeah.
Right.
So all these guys are breaking at this point.
Yeah, I see. Huh. So everything is in the docs.
Yeah. Yeah.
Okay.
And I'm not even sure how this person got hold of those examples. Where are they seeing this from? This is from their root GeoSci.xyz?
I think if you actually go to computation.geosci.xyz, I don't think it's on the, yeah, so it's not easy to find, but if you actually go to computation.geosci.xyz, it does exist. So if they somehow Googled the right thing, they could have landed here. We haven't really advertised this page much.
Cool. Well, yeah, why don't we just bring them in then? Under the examples of SimPEG.
Yeah, I think that could be, that's probably the most straightforward thing to do at this point in time.
Okay, so yeah, on my side, I will start converting those notebooks into a Python script to be able to compile on the site, and then you can decide where you want to bring it.
Yeah, sure. I think putting them in the SimPEG examples is probably sensical. For things like pixels and their neighbors, we might want to start a tutorials folder. And is Devin in the room? I don't actually see.
He's not far.
Okay.
I'm listening.
Hey, Devin. Well, because Devin did a really nice job organizing both the examples and the tutorials in Discretize. And so Dom and Devin, if you guys are game to work together, that might be, yeah, just a productive way of moving forward. And maybe you can sort of divide and conquer some of the examples so that, you know, not one person has to carry all of them.
Well, I've actually already gotten started on it. Obviously, I'm not spending loads of time because I know the simulation stuff is going to get merged in and sort of the way core modeling is going to change.
Deb, sorry, I think we're there's something very specific we're talking about here. So there's, Dom, do you still have your screen up? Would you mind giving him a quick overview?
Yeah, one sec, bring it back. So these, we have a bunch of notebooks that exist under computation, the GeoSci.xyz. They're not exposed, but someone has managed to get to that side.
Oh, really?
And all those books are breaking because they're not up to par with master. So we're thinking, let's convert these guys back and bring them back to the.
I see. Okay. Yeah.
There are a really nice set of examples. And I think we actually put a fair bit of time into describing what's going on. And so, yeah, I mean, converting these just into basically SimPEG examples, I think would be extremely valuable, both for the docs and just for like the wider community.
I guess since they're technically published posters, we could put them under the the SimPEG examples. We have a publish section, right?
Yeah. Yeah, so under the examples, there's the in publications. So if there's some that were specifically published, let's put them there. And then if there's others that are just examples, then we can stick them wherever else makes sense.
Yeah, I'll work with Dev on trying to find a place to migrate those then.
Excellent.
But yeah, so there's an issue right now that I just created for this, but work on it later.
Okay. Well, I mean, if you want to, like, if there's one sort of specific thing that this person was looking at, and you want to do a quick fix and push that through, like, that's totally fine. You know, to get them up and running. Whatever's best.
Yeah. I basically answered them and gave them a fresh one, but at the same time, it would make sense if we do it on our side. We give it to them, right? Yeah.
This actually, I might jump in with my update if that's okay, and then we can circle around, because this is totally relevant as well. Because I've noticed, especially Dom, you've been fielding a ton of questions, which is awesome and extremely helpful. And I'm wondering, so I've seen like some of them, it looks like we actually are in place where we're in a place where you can send them a link and it's like, here's what you need to know, or here's an example that you can use to answer your question. But that's not like always the case. And Soggy, I've noticed that too, even with like Craig, there's not always examples for like what they're looking for. And so I'm wondering if there's a trajectory where, because Devin, I know you're invested in working on some examples for the docs. So I'm wondering if there's a way where basically, if there's a question that comes in that we don't have an answer for, if folks can work together and get connected so that Devin has the tools that he needs to actually just like create an example that you could then send to that person in the future. So even if you need to immediately answer the question, like that's fine. But hopefully the outcome of like any new question basically should be that if that question were asked again in 2 weeks' time, we just have a URL that has an example that's reasonably well documented that we could send that person. So some of this might actually just be like, some of the examples don't have much text in them. So some of this might just be like Devin perhaps just sitting down and chatting with whoever created the example and saying, you know, can you tell me what you were thinking in this step? And there might be other cases though where we do need a new targeted example.
Yeah, I tried to design the tutorials to sort of be if you were going to try and answer all the basic questions, like how do I create my survey and how do I go and do this sort of basic forward simulation or something like that. So I find a lot of the time when I'm answering questions, if you had a very basic tutorial, simple example with enough text, that it would answer 90% of the questions we get asked. So that's sort of my goal of the tutorial is if I want to do a basic inversion, maybe I've got some data, maybe XYZ locations and some data, and I would like to create my survey, create a mesh based on that survey, run maybe a simple L2 inversion. So that's sort of where I'm coming from in terms of these examples.
Yeah, totally agree. And I think that, so all that I'm suggesting is that rather than, it's just a question of which way to approach this problem. There's one way where you can identify, like, here's the entire suite of tutorials that we need to solve the problems of any user. So that's sort of step one. That's like a build it from all of the building blocks approach. What I'm suggesting at this point is let's focus in on what are the current questions that we are fielding, and make sure that the examples address those first. So it's just a question of prioritizing. But I think because we're getting so many questions coming in, that focusing in on like, let's just make sure that we have examples to answer these exact things, that might help us more so, especially in the short term while we're doing some refactoring and such, rather than sort of sketching everything out, and knowing that, you know, some things are changing, some things will continue working as they are. Does that make sense?
Yeah, I think maybe I'll take a look at the host of questions that have been asked and see how much of that have been covered in the stuff that I've created so far, and then also just try and find a way to incorporate the other remaining questions into what I've been doing. Kind of a way of maybe doing it a bit simultaneously.
Yeah. And then I think too, actually taking a serious look at what we already have and improving a lot of that, because there's a lot of good examples, but many of them right now are basically just like, here's a wall of code that solves a problem.
Yeah.
And so if you're able to go in, and I think that that's actually a good starting point for learning SimPEG too, is if you're willing to go in and actually just like outline step by step what's going on in the stuff that actually already exists.
Mm-hmm.
Yeah, and then the other thing that I'll ask with that, just because like my plate is getting pretty full here as the fall term's getting up and running, is just that for pull request reviews and things like that, if folks who like helped prompt the creation of a tutorial are willing to jump in and help out with a review, that can streamline things. And if you give a thumbs up, but need help merging and stuff like that, like I'm happy to do that. And I'm happy to sort of answer targeted questions, but if we can spread out like where and when reviews are happening, I think that'll help smooth over, you know, any individual's busy schedule. So cool. I'll jump back, throw things back to anyone else at UBC who has updates, things you'd like to share.
Lindsay, before we move on, like, so what's the plan of, like, let's say I got a question from Craig.
Yeah.
I answered it. I basically got a script of the code I provided him. So, I mean, that's not really kind of exposing those solutions to the other people.
Yeah.
So what do I need to do then? Like, do I need to, I don't know, send the gist of it to Devin? Or like, do I need to make an issue, or do I need to make an example? What's sort of our, like, I don't know, what are we doing here?
I think in some ways this is a question for Devin. So like, I mean, if Sagi sort of had the start of an example, how do you two want to work together? Because I mean, Sagi could start a rough pull request and you could work from there, or an issue, or what do you think is the best road forward?
Think about that a little bit. One thing that I've done for the repository is put a directory kind of for pending examples or pending tutorials, things that a place where you can work on stuff, but that you're not ready to link it up to the website yet, and you're playing around with it a bit more. But I have to think about that. I like the idea of making an issue.
Yeah, I think on my end, the easiest way, like, I could make an issue and provide a notebook that I provided to, let's say, Craig, and then put a description what the question was and how I answered it. Like, that's probably the easiest way. And then if David can turn that into either example or whatever documentation, that sounds like a good workflow on my end.
Well, we did something like a GitHub issue, and it had a specific tag, like a tutorials tag. I'm just trying to think of what happens when maybe there's 6 going on at the same time, how to really keep that list organized.
Right.
You can't have everything, you know, working on a single branch. So I mean, maybe if there's a tag on GitHub that says a tutorial, so I can just search for all issues pertaining to new tutorials.
Yep, that's totally something we can do. We can create that tag. One quick thing with creating examples, I think this is an implementation detail, but it will be easier if for like each issue there is a new pull request. So if there's just a single example, there's a single pull request that goes to that. So not trying to map a branch with a whole bunch of examples to many issues. If we can keep it sort of one-to-one.
Yeah, that's what I agree. So we have one issue, and that would correspond to one branch that would have one pull request.
Yeah. Yep. Yeah, and then and then we can make it so that it's easy to search for the tutorial issues.
I got one more for UBC. So we started doing the review for the third version PR.
Sorry, for the what PR?
The pull request for joint inversion
Okay.
from Jaja's grad student. I can't remember his name.
Jay?
Yeah. So Thibault, that would be great if you can. You're going to be working on the exact same directives and everything.
Yeah, like I think we have like some stuff that is like review overlapping between.
Yeah. And he has a beta directive to be able to do like some like re-leveling and all that stuff.
And
so,
I have my own.
And I have my own too. So that's all merge the same stuff. That's great. He's using a lot of like he's building his own operators. So I think that's one for Joe actually. I think he would like to be able to do backward difference or even center difference. It's probably not hard on your side to have this, right, for tree mesh, to be able to do backward differences?
No, not at all. It's just make sure, I mean, I was looking through his code before, and I know there's a lot of instances of creating some, like he's actually creating dense matrices of the meshes at some point, so we gotta watch out for that. But yeah, I mean, I think there's a little bit simpler way to implement the gradient operators that I've done in my own stuff. So, or at least to use arbitrary gradient operators inside that cross gradient operation.
Yeah, right. And I was wondering too why can't he just average his gradients to cell center? Because I understand that he needs to do the operations in cell center, but like he's doing a center difference. I'm not sure if that's necessary either. Anyway, stuff that
I mean,
I'll ping you on.
I mean, if you do like a forward difference and then average it back to cell centers, that's basically a central difference.
Exactly.
So it's just a key of making sure that everything stays in the correct place.
Right. That's what I figured. Okay. Well, I'll ping you, and then maybe I think it would be nice if we have the option, though, even for tree mesh, to do either forward or backward difference,
On cell centers.
I'm sure someone will ask again at some point.
Yeah, sure.
Thanks, John. That's awesome. Anyone else at UBC or Sagi? Do you want to jump in with any updates you have?
Yeah, I don't have that much update. I just got a question for Dom. I was playing a little bit more with the sensitivity weighting and also the preconditioning. Do we have like a tutorial about that?
Just for that? No, I don't think so. No.
Okay.
I've got a place in my head for something like that too.
Yeah, kind of. So I'm using that for kind of EM problem, and yeah, I wasn't exactly sure what's going on. So yeah, it kind of would be nice to have some tutorial when to use or not.
Sounds good. We should, yeah. I mean, it's baked in. It's baked in all the potential field examples, right? But it's, as Lindsay said, it's all part of one big.
I'm happy to help, and I do have some example. And it seems like all your LP inversion, it's all kind of, everything's supposed to combine together well to have a good performance. It seems my feeling like I'm basically playing with your codes and getting some good result in EM problem. But yeah, I wasn't quite sure. Anyway, so just kind of curious. Do you have a tutorial or some example about that?
Yeah, definitely should. I mean, yeah, definitely has to be done.
Yeah, and also in terms of convergence, do we have some good measure that whether that LP inversion is converged then?
Well, we're doing conversions based on how much the functions are changing. So both phi d and phi m.
Okay.
Yeah.
I see. Okay. Anyway.
There's no way to guarantee that you're at the global.
Yeah, I checked your example. Like, you ended up having 40 iteration or 50 iteration for LP steps. I think.
Yeah, but they level up. It's just our criteria to quit is a bit weak right now. We're kind of like, we're hardwiring how much we're letting the functions change. Okay. But often you can quit earlier. We just need to be have something a bit smarter, I think.
Okay, sounds good. Yeah, I could. I have some examples. Yeah, if you can help, that'll be great. Okay, thanks. Thanks for that. Yeah, and yeah, I kind of want to. So I mostly worked on 1D code recently, and yeah, I want to like turn that into a newer simulation class, and also I want to merge that into SimPEG. Yeah, so that'll be kind of sort of my to do, and I think that the only reason why I didn't merge in was that because that Fortran code. So I wasn't exactly sure. Like it's somewhat fiddle. Like it's like you need to set it really right, and it's working. So you could put it on a binder, but I wasn't exactly sure whether like is it okay to bring those Fortran code into SimPEG or not.
Let's maybe start, if you're game, to start an issue to discuss this, because I think we can think through this. I want to make sure that like pip install SimPEG still continues to work easily for everyone. So we might need to like think through what the installation process looks like, or if the Fortran piece is actually sort of a separate repo that like you can install, and if it's installed, then we use it, and if not, we use the Python code. But I think, yeah, we're just going to need to, spend a few cycles like thinking through this, and we can sketch that out together if that works with you.
Yeah, that sounds good.
After playing with GenPy and getting through all the pain of installing it, I might have found a Fortran compiler for PC that is pip installable. So I'll double check with you, because that could solve our problem. We didn't have to like have a Fortran compiler. We could just add a pip.
Well, currently, Dom, what you have posted at one point, how compile like using the Visual Studios and stuff. Like, remember you?
Yeah.
Yeah, that.
Fortran. Yeah.
Yeah, I think that kind of worked out for like 1D code. I think I just used the Fortran compiler in there, I guess. Like there was a specific instruction that you made at one point.
No, yeah, that's on a separate installer. It was TDG.
Yeah, exactly. Like that kind of worked, but
we might be able to skip that part. That's what I'm saying. There's a pip, pip GCC that we might be able to use instead. Yeah.
Okay. Sounds good. Sounds good. Yeah. Kind of related to that, I'm giving a talk in LBL, and yeah, the theme will be like use of like airborne electromagnetics in groundwater application or groundwater management. But yeah, basically this is the workhorse tool that I'm using. I kind of want to, at the end, I want to introduce like everything that I used here is available, and they can potentially use it because like they are handling quite a few airborne data, but I think my feeling in LBL, they're not that many. Well, in the environmental group, I guess, like there are not that many people really actually handling EM data because like they usually use whatever resistivity product they've got from somebody and using like fancy technology like machine learning to extract some information. But I think it'll be nice to show them, okay, here's a tool that you can actually start from the data.
Sagi, what time is your talk?
I think it's 11.
Okay. Well, I will be there.
Ah, thanks, Lindsay. I'll see you there.
Yeah, that'd be awesome. And so to share stuff, do you have something in mind? Like, do you want to create a binder or do you have?
Yeah, yeah, but that sounds like a good idea. Yeah, binder. Yes.
Cool.
Yeah, I'll generate one for like a research repo.
Yeah, that would be awesome. Ooh.
Okay.
All right. Any other updates, or can we turn things over to John with his work on Dask? John, the floor is yours.
Okay. Yeah, so yeah, I'm just going to go over the 3 areas that I've been dabbling into. Let me share my screen. All right, can everybody see that?
Looks good.
Oh, okay. Yeah, so yeah, just applying it to our data sets in the industry here. First off, our DC and IP, we've been using pretty extensively, mostly tensor mesh, because that's the one I've convinced everybody on so far. And clients have already come back to us saying how much they've enjoyed the inversion of the models, and very good stuff. And hopefully SIP soon. I got to get Charlotte in touch with Soggy here right away. Full tensor, pretty much a lot of the stuff that Dom's been doing, just piggybacked off of him and got some great results there. And then magnetotellurics. Yeah, just trying a whole bunch of different styles. So first, yeah, so early on, I managed to get the tensor mesh going pretty quick for everybody. And here's an example of some of the larger inversions. It's like a 7 million cell tensor mesh, like 700,000 data points, 800 injections. Yeah, it was pretty big. Takes about a week to run, but you know, it's pretty doable, not too bad. Yeah, so I guess you can see, I'm just gonna move that there. So in the corner here is the chargeability. Then we got our chargeability and resistive structures there. Mostly what we do is just a little bit of surface weighting, maybe play around with the errors a little bit. We have a little bit of a calculations that we'll do ourselves to see how quality the signal was. And yeah, we've been getting really good results. So the next thing I was doing was getting Octree hopefully going, because to run one of these inversions, we need to put it on one of our big computers that has, 80 cores, run it for quite a while. So coming here, you can see we like to include the potential and current remotes, so you can tell if that, or you can see that if it's a tensor mesh, it's really gonna add up quick. However, so running to Octree right away. The IP model actually really well, not too much of a problem there. It was when we got to the DC, the tensor mesh kind of trims everything around here. If you can see my cursor. That's usually how far it'll pull deep. Whereas the Octree, it seems at at the levels, it just kind of goes through all of them and just like pulls everything down deeper. We'll be cutting off the survey right there. It's just a lot of my colleagues and stuff are kind of concerned why it's doing so much at depth. However, in the area of concern, these 3 guys here, for this example here, correlates to these little 3 guys, and that's of interest to the geologists that we were working with. So all in all, the Octree is working pretty well, getting results that we want. Just, yeah, a little concern on what's going on at depth, why it's building stuff. And then also at the interfaces, you can kind of see the model there's a little bit of a distortion here and there. However, I talked to Dom about this, and then so he showed me an example with the simple, and that's actually what this last one is simple. But changing from a Tikhonov to a simple inversion, it kind of changes the model quite a bit.
So John, what's your alpha S value?
For simple, I think I kept it at 1 e to the negative 3, whereas Tikhonov, we've put it at 1 e to the negative 4.
And what is your cell size?
Cell size for, we go half depth for the width and length for tensor mesh. And I use, I guess, so in this case, it's 12.5 for all of them in the octree.
Yeah.
I was finding actually, without using the square cells, using what we would use in the tensor mesh, that distortion is a little bit more prominent, but yeah, nonetheless, it's still there.
Are they both on the same color scale, both same color range?
Yes, that's correct.
So the reference has changed or no?
Oh, you know what? Maybe that
Because
does.
the backgrounds are very different, right?
Yeah. Good point. You know what? I have to take another look at that. That is, I wouldn't think it was, but I did grab the script from one of my colleagues. Yeah. Okay. I'll have to double check that. But yeah, as far as I know, they were supposed to be the same.
The main difference between Tikhonov and simple is that the gradients are calculated differently for the regularization. So it's not surprising that you're getting you don't get that discontinuity in simple.
Okay.
Yeah.
And like by default, simple doesn't account the volume, right?
It does now, yes.
No, so simple counts the volume.
If you don't put cell weights, if you input cell weights, then it overrides the volumes.
Yeah.
Ooh.
Yeah.
Dom, is that something I think we talked about, just like the potential confusion of that step and potentially wanting to actually have cell weights in there, or sorry, the cell volumes always in there, and then if users want to include cell weights, have that be separate? Is that still something that's on your radar, or do you think that that's important? Or is that a conversation for later?
Yeah, maybe it's a conversation for later. Yeah.
Okay.
Well, I think here the main issue is not the cell volumes, is the way the gradients are calculated for the tree meshes, right? So the main difference between the two here is that in the simple case, we're doing gradients for each of the hanging faces, where for Tikhonov, it's a single gradient over 4 faces, and that changes the solution. That's the main difference. Yeah.
And one thing you may try is just put a much smaller alpha S value, John. I think my experience, I like if you just like that kind of comes in when you are using different alpha S value because you got different volume size. So your regularization actually also, like, not only your gradient, you also volume makes a big difference.
Yeah.
So yeah, just using somewhat like very small alpha S value could help.
Okay, cool.
Yeah, I didn't have that much problem when like I was using OctreeCut for EM problems.
Oh, okay, cool. That was one of the other things. This is like a combined data set with pull-dipole, dipole-pole, and pull-pull, and it seemed that this was kind of arising more in the pull-pull data, but I guess that's because it's trying to do something more in depth, whereas before, there was nothing there sensitive to it, so we didn't see it.
Yep.
That'd be my guess. Yeah.
Does the code output then what the final values are for each component of regularization?
No, Doug, right now we don't, at least it's not in the iteration printers. This is something that we actually should allow some flexibility. I think Soggy froze, which is why I'm jumping in. Right now, the printers are, we do like Phi-D and Phi-M. If you, you can write a directive that would print them out, because we do have access to all of that. Actually, Thibaut, you might have done some of this already. Have you changed what's printed to the screen?
Well, yeah, I haven't changed really how have the thing that's organized, but yeah, like at regular intervals, I output like the value of phi s, so I don't have to check. But I haven't done like something very, yeah, like very advanced, like it's like adding a column or etc. It's like an extra line mostly.
Because if we come back to what this discussion has been, I mean, alpha S is, whether it's big or small, actually does depend upon the volume that you're working with. So alpha S is 10 to the minus 3 might actually be a pretty small number if you've got something that's only, you know, a couple hundred meters across. But if you've got something that's a couple of kilometers, then to have the same kind of relative weighting for those components of regularization, alpha S might have to be 10 to the minus 5. And an easy way of just kind of getting a first pass assessment of this is just if, like, okay, in the regularization function, just print out each component, and now we find that that smallest model component is 10 times as large as any of the gradient terms, then you know, like, oh, wait a minute, alpha S is really big for this. It's just a quick diagnostic that can help a lot.
Yeah, I think there's a save output every iteration dictionary, and if you use that, actually that outputs each component. Yeah.
Oh, it does.
And what would be nice if someone's game to give this a go, because I think it actually should be reasonably well scoped, is actually in the optimization code to perhaps like just change the verbosity, and so be able to say, like, you know, right now is the default is 1 or whatever, and be able to, you know, set that to 2 and have that actually output all the components of the regularization. It should actually be a fairly well scoped pull request. So I'm happy to point folks to like where you would do that. But that would be a really cool contribution.
Interesting. Actually, Lindsay, could you reword that one more time? Or?
Yeah, sure. So it's right now, I believe that all of the printing is done inside of the optimization code. So there's the code that we have for iteration printers.
Oh, okay. Yeah.
And so right now we have basically like what is printed out.
Okay.
So it shouldn't be hard to go in and add basically like X number of columns, where X is the number of things in your regularization, to have that be also printed out when you're running the inversion. So,
cool.
And actually, like the code that Sagi mentioned in the directive, it's already showing you how to access all of the things in the regularization, because it's grabbing all of those numbers and then dumping it into a file. But it would be nice if we could do the same thing just to the terminal so that you can just have an eye on it while it's running.
Cool. Okay. Yeah, I'll take a look at that. If I'm going to be diving into here, I can probably get into that.
That'd be awesome.
Yeah. Yeah. So I guess next is kind of the stuff that mostly I've been trying to do here. First is using Zar to store J. Using Dask, I can create J. The only thing is, I'm finding that so how I make it in Dask is I make a list of all the sensitivity matrices from each injection for each source receiver. I guess each source will have its own matrix. And since it changes for every injection, that's where Zar is having problems that I'm finding here. Let me go up to, where's my get J2. So I bring it into here, and I have experimented. So if I make a Dask array or a Dask object that just was a bunch of vectors of all the same length, X amount of vectors, I can write to Zar, no problem. But now that since they're all different matrices, I still form, I guess I do a VStack of the Dask operator, and all my shape, that seems to work out. And then even when I go to rechunk it to make sure that it's going to write out the same things, I keep getting an error message that says, please rechunk your data before writing to Zar. I don't know, have you ever seen that, Dom, when you were playing around?
Yeah, that sounds familiar, yeah.
Was that because of the similar thing? You had, when you were building everything, it was a different matrix size that you were building it out of, or?
But do you need to put all your injections in the same ZAR? Could you just like write out a ZAR per injection?
Oh, write out a ZAR per injection.
You could, right?
Yeah, that's actually one of the things I was going to ask, if that would be acceptable, if that's still going to speed things up.
Well, we can talk about it offline. Yeah.
Oh, okay.
Yeah, I'm not sure why they have the different size, because it's the same mesh and it's the same mesh, right? They're all on the same mesh.
Yeah, so all the cells are the same, but you're going to have different amount of receivers per injection.
Oh, okay.
So it's the N part of the N by N matrix. It's just that one changes all the time. You're always going to have the same vertical, or like the same cells in the one direction, but different in the other, and that's where it's giving me or spitting errors at me for.
So they should stack well in one direction then. Yeah.
Well, that's the thing. I just do like a da.v stack, and I get the proper shape, but it just keeps yelling at me that it needs to be rechunked or something like that.
Yeah, let's talk about it after. Yeah.
Okay. My other thing so for the preconditioning, the preconditioner only uses get JPJ, so I would only be grabbing a vector essentially if I wanted to use preconditioning, right?
You would do the row sum, a dask row sum, right, on your J.
Okay. So if I wanted to use the preconditioner as it say right now, I would just have to form J as I have, and then just do a sum over it and then pull that in.
Yes.
Cool. Right on. That was my other question.
It will do the row sum chunk by chunk and then add it for you. Yeah.
Yeah. Okay. Cool. So yeah, I should be able to have examples here using the preconditioner with a pretty large DC survey. I'll try that out at the very least. And then I guess after that, I'd like to try the tiled inversion, because that was really successful in the full TensorMag stuff. Oh, it's been amazing. I can invert so many data sets on like a laptop. It's great.
Yeah, that's pretty impressive. I know. It's great.
And then surface weights for Octree. I've been having a problem. Maybe I'm just not assigning them right, but it seems to really push my beta down, my beta naught. It'll start at like 1e to the -10 kind of magnitude, and then even jump to even higher to like -20 or something like that. And
Which problem are you talking about here?
For using surface weights, applying it to the Octree problem.
For DC.
Yeah, for DC. Yeah. Yeah, I'm trying to, how can I word this? It almost seems that if I don't have a really good DEM that covers the whole mesh, I'm going to have really big blocks on the side. And those blocks, if they're associated with a surface where I could start the surface weighting, I don't know, that just, to me, that seems like where things are going wrong. So is it maybe the way that I'm formulating how to use the cell weights, or is it maybe the difference in cells? Do I have to take into account the size of the cells themselves when they're being applied?
Did you normalize your weights?
I did not.
Yeah, normalize your weights, because I think by default the beta estimator is not applying the cell weights, and so you're probably gonna have a huge jump in the scales. Yeah,
that's totally it. I should have thought of that. Thanks, Dom. That's a good point.
Try it.
Yeah. And and then the last thing I worked on is I made a forward model script using the simulation class. I kind of made it for, I guess, in-house, but it could be technically drafted. I was talking to, I can't remember, one of my colleagues there. And so we made it so that you can just pull in like a CSV file of all your electrodes, and then you can pull in a topography. So I guess it's meant more for planning a survey, and we can use this to, you just throw in your electrodes, tell it what kind of spacing you want, how many injections you want, and it just uses the simulation class to produce a forward model. On anything you want, any terrain, any electrode arrangement, you go from there.
That's awesome. I mean, if you wanted to start a pull request on we should figure out like what the name of that like style of module is, because I think that we talked a bit about this in Montreal, but the idea of like sort of wrappers or drivers or SimPEG Express or something like that, that's basically sort of like a high level API that sits on top of SimPEG, that if you have set up your inputs in sort of a specified way, like what you're saying with the CSV file, then we can just take care of a bunch of stuff for you. So yeah, I mean, if you want to start a pull request, and any like name ideas for what this module is called would be great. And that goes for anyone, is if you have ideas of what to call this sort of like high level API. Yeah, I think there's a lot of value in having stuff like that.
Yep, I'd put my mind to it. Yeah, so for DC, that's practically what I got there. Next is the full tensor. Can't quite talk too much about this because it's a very hush-hush data set, but here are some pictures of it. Yeah, big time mesh. I ran this on my Mac. It's really, it's only about 4,800 stations after downsampling, but yeah, it, it worked out pretty well. And because of the tile, the Octree and the Czar, that's all DOM right there. That's super fast. And that's awesome. Great. Yeah, and then the Cartesian and the spherical. I've been really enjoying that too, the difference, or being able to use both of them. As you can see here, it seems that the spherical, again, seems to reduce the spread. Yeah, to go into more example here, this, I guess it's kind of up here. It's this little area here was the area of interest. And this is what they were producing. And most of their results were the one on the right here. And they were kind of questionable about this right here, like how real it is, or, you know, how, is it something that should be investigated? And as we go into like the spherical, then using TMI with the gradient components, it's actually showing that, you know, it might not be the most important part that they were looking for. So they were really, really happy to see a discrimination between those two lobes right there. Yeah, all due to gradiometry. The way that, yeah, I haven't really developed a way to assign the weights so much. Oh, I guess those are just the residuals. Yeah, just kind of by re-inverting an inversion every time, just kind of seeing what the residuals are afterwards. I'll either bump up or bump down the components. I guess that's probably another thing I should rack Dom's brain or anybody else's, like this, using this kind of, like, how can this be automated in a sense where you can afterwards do an assessment and kind of narrow in, because it took me about 4 or 5 like goes at it before I found a nice right threshold, I guess, maybe to say. Maybe there's a way to be a little bit more effective. Maybe this was kind of similar to what Sean Walker was talking about a while ago when he had that talk. Yeah, it seems to be pretty promising for the potential fields here. I'm really enjoying it. And then next is the magnetotelluric stuff. So, yeah, I'm kind of new to MT. So I've run a few inversions. Like up here, you can see the actual model, and then what I'm resulted afterwards. The inversion runs, and it seems to fit the XY and the YX for most stations pretty well, but a lot of the XX and the YY turn out how it's showing here, which is, I'm guessing, the reason why my recovered conductivities are higher than they should be, or just not, they're not recovered to what I was expecting. I don't know. Comments on maybe it's weighting, or is there something to MT that I'm kind of missing that should be addressed? Or just really plug it in like every other inversion kind of thing?
I can't see scale.
Can you zoom in?
But I mean, generally XX and YY are really small compared to the.
Oh, and that is the case here. Yeah, you're right.
Yeah, so if you're going to get the data and then trying to think about the relative errors between the XX and the YY, if you just tend to use you know, a percentage of the values, that, you know, that might make it more difficult to fit the diagonal components. Anyway, something to be cautious of, just the magnitude of those diagonal elements compared to the off ones.
Okay, nice. Magnitude of the diagonals. Cool. All right. Yeah. So that one also, I've started bringing this over, or I've taken the 3D example on SimPEG there, and have started bringing that over to the simulation class just to try. However, when I run it, my first iteration, it crashes after the first iteration because both my phi D and my F come out as NaNs. But if I run it, if I run without simulation, if I use the problem class, everything seems to work okay.
Oh, that's problematic.
I've got notebooks that I can send of them both. Maybe someone take a look or something, or.
That would be great if you'd be game to post. I mean, feel free to post it actually right in that pull request and just so you're getting some funky results. Yeah, because that's concerning.
Okay. Yeah. Yeah. I tried a few things, just playing around, regularization and whatnot, and yeah, everything seems to be giving me the same NaNs for those.
Yeah. So I'm guessing something is probably going wrong very early on. Yeah. So I'm not. We can dig through that. Yeah.
Okay. Well. Yeah, that's cool. And then I've also tried a modified MT, where there's just a single E field receiver on the ground, and everything else is collected B field in the air. And it seems that the model wants to pull the anomaly towards where the E field is stationed. My guess is, would the sensitivities have to be modified, or is this, I think we were talking about this before, Lindsay, maybe weighting in this case as well?
Have you tested the sensitivities for these? So
I have not yet, no.
Okay, so that's a first thing to do.
Okay.
There's some example, so a lot of the tests, you can have a look at basically any of the frequency domain or the MT tests. The frequency domain might be slightly easier to sort through, I'm not entirely sure. Okay. Yeah, because that's the first thing to check, is just make sure that we are walking in the right direction. So the sensitivities should converge second order. And if not, then that means that there's something we need to go in and hunt down.
Okay.
If they are correct, it might be that, like, for something like this, maybe there is some weighting that's needed. I don't know, Doug, do you have an intuition of if you have a single E field receiver?
No, not really.
Then yeah, let's check that the sensitivities are correct before we sort of go down too much of a rabbit hole.
Yeah.
Yeah. Well, like basically all the magnetic receivers sharing that E field receiver at a single point, correct? So, I mean, like, you're gonna have a huge sensitivity at that point, I guess. Like,
at that point, yeah. Okay.
But yeah. Anyway.
Yeah. Yeah. I can do that. So look into. You said so. Look into the tests under the frequency domain. Probably the easiest one to start with. Sorry.
Yeah. And there should be one called like test JVEC, or something along those lines.
Okay.
Yeah.
Can do. Yeah. And then yeah, I just ran a tipper one of the same situation. Just kind of tipper in the air. Just move the block around, and things seem to work pretty good. Perfect case, but it seems to work pretty well.
That's good.
The conductivities are a little bit higher, but not too much more. It's pretty well recoverable.
Nice.
So then there, yeah. So what I've found with the parallelization, I've used Dask, and then I tried multiprocessing at the same time, doing it over frequencies. And multiprocessing is about 20 seconds faster. Dask is about a few seconds faster than that. It's where the plug is doing the A inversion, because every frequency you need to run the solver. Mm-hmm. And that seems to slow everything right down. So it doesn't matter if you have it parallelized, it's still being hogged by every one of those, or the solver trying to pull up resources to process for itself. So yeah, I guess this is kind of what we were talking before the meeting there, Lindsay. I don't know what I was thinking is there a place that we could calculate A in for each frequency and store it? Would that be an idea? Or you mentioned something, yeah, telling Dask how to serialize and deserialize?
So I think there's a couple things going on here. So the serialization and the deserialization shouldn't affect AN. That should affect when you call fields. Yeah. That's where the serialization, deserialization of the fields object could be.
Oh, yes, okay, yeah.
The AN term, so the question I have here is, are you using, is this multi-threaded or multi-core?
Actually, I did multi-core on that.
Okay, and that's still... Because so multi-threaded, I could see that being problematic because the solver is basically going to try and go and grab all the threads. Yeah. And then if you're trying to run multiple frequencies at once, no matter how you're parallelizing, the solver is parallelized differently. And so we sort of don't have control at that level. If it was multi-core and each frequency is being sent to a different core, I would be surprised if there's sort of competition between them.
Certainly with multiprocessing, I tried using multiple different cores, only giving it so many so that the solver could grab up what it wanted to, but no gains at all that I saw.
But okay, but when you're using Dask,
yeah,
are you setting up?
No, Dask is using cores as well, I believe. Where do I have that? Oh, that's not that one. Oh crap! No, not that button. Well, now I can't get rid of that top. Okay.
That's all right.
Okay.
I think maybe the thing to do is, because I think this is going to take a little bit for all of us to sort out, but I think there's a few of us who are perhaps working with this right now. So I'm doing work running simulations on NERSC using Dask. So I've been successful in just basically sending jobs to different cores and getting SimPEG results back. That's sort of a simpler version actually even than what you're working on, because I basically just serialized a simulation, sent it over, and then said, send me a vector back when you're done.
Yeah.
But just sort of playing around with Dask, there's different, depending on where you're running it, I'm not sure threading versus grabbing cores. I think that there's potentially a couple subtleties in how you set it up.
Yeah, maybe I'm not. You're right. Okay. Yeah.
One comment, John, you can set the number of thread that you could. There's if you look at the PyMKL, there's a function that you can set the number of thread that you would use for your when you're using Pardiso.
For when you're using Pardiso. Oh, okay.
Correct. So by default, it used all thread that you have.
Yeah.
So if you don't set it right, it doesn't really matter whether you parallelize it or not, because it'll try to all of them in both cores. So yeah, you wouldn't see any speed up.
Okay, so I thought I didn't. We do have control over what solver uses then. Sorry.
Yes.
Okay. The PyMath solver, you said, or?
Yeah. So from PyMath solver, there's a Pardiso, right?
Yeah.
But if I can send you a command that how you can do it.
Okay.
Sagi, would you mind posting that in one of the general channels? I'd be really curious to.
Yes, because that's one of the important part. Because if you think about okay, I'm gonna parallelize it 10 cores, but each core has X number of threads, so you don't want to use too much threads.
Yeah.
Okay. Yeah, I could do that.
Cool. Thanks, Augie. Yeah, that'd be good.
Right.
Yeah, so other than that, I've tried to move it over to the simulation class as well, and that's about as far as I've made it. So.
Yeah, and also, John, there's rather than using Pardiso, there's a iterative solver. I think it's a BiCG Jacobi or something like that in PyMath solver. Try using that, because you'll see I don't know, like a, yeah. In that case, there's supposed to be some improvements, I guess, even if you don't store a in.
Okay. Sorry, that was called an iterate, or is an iterative solver, you said?
It's a BiCG Jacobi or something like that from PyMet solver.
Okay. I'll throw that into the mix too. See what.
Right. And also, if you want to use ZAR there, I think like you can use ZAR to store fields.
Oh yeah.
So that'll kind of like the memory issue for a EM problem, particularly for MT. I think that's actually not a, well, if you have really large cell, like a in will be expensive, but mostly it's fields. So yeah, if you can store that, and that could also save memory and potentially speed up as well.
Okay. So could we store ZAR as an object, or would we have to turn it into a vector and then save it to ZAR?
Could be an object, yeah.
You can save the object? Okay. Okay, cool. Right on.
Oh, hold on. But fields it's a vector.
Well, there's a subtle difference. So the fields is an object, but there's one vector that is actually meaningful. And so I think that for this case, I think that you would actually only want to store like the solution vector as ZAR, and then have the fields object know how to access ZAR to do meaningful stuff with it.
Oh, yes. Okay.
Sagi, do you have an example that does that for EM? For the fields?
Oh, storing ZAR, like storing fields into ZAR and then reading. No, I think I could help, because like that's generic functionality, and yeah, I kind of want to have that as well.
That's cool. Yeah.
So which branch are you working on, John?
Oh geez, which one do I think it was simulations JK.
Okay. Yeah, I'll take a look, and I can point a couple of things.
Yeah, I think I got to push some changes here, but I'll do that right after the meeting.
Okay.
And then, John, if it's helpful, feel free to start a pull request onto the simulation. So from your simulation to simulation JK, if you just want something that's sort of like tracking what's going on, that's totally up to you, but it might be helpful to have a place to comment on.
Sorry, so that mine is tracking the other simulation branch?
Just to start a pull, so yeah.
Okay.
Yeah, just to start a pull request, just so that like if we can go in and just like comment on the lines of code and things like that, if there's something you want to have a conversation on.
Can do.
Excellent. Well, we're a bit over time, so thanks everyone for sticking around. Are there any other, well, if anyone needs to leave, feel free to do so. But if not, if there's any other questions for John, feel free to chime in while it's fresh.
I was just wondering, is there any merit or reason to do some cross-checking here of the SimPEG MT codes with the UBC code, just as an added verification, like maybe running the same examples to see what we get?
That would be great. I was trying to get some other colleagues to work on some of the analytical solutions so that we could at least compare it to something there. But yeah, we're essentially trying. It would be a little bit easier to sell to the bosses and stuff if we could have a comparison to something.
Well, I mean, the manuals, the online manuals, as of right now, they're open. There's a downloadable zip file. And you can go and get some synthetic data for an L-shaped conductor. And, you can go look at that manual and see what the inputs we use, like the cooling schedule and what have you, the alphas, and you may be able to reproduce those results exactly.
Nice. No, that would be great. So that's on the UBC GIF site?
Yeah, I'm making some changes. I'm fixing a couple of broken links this afternoon. So if you give me a few hours, you would have access to that. I could send you a URL, but it's all that natural source stuff that we were talking about a few weeks ago, just some resources.
That'd be cool. Right on. Yeah, I think it'd be great merit to that, especially with all these other new styles of MT, the AFMEG stuff, expert MT doing it, the Tipper and all that. Trying to, make sense of it all.
Excellent. Well, thanks, Sean. This is really exciting to see you're pushing hard on a whole bunch of avenues, and it's awesome that, you're able to push stuff. I think, 7 million cells has got to be up there for some of the largest inversions that have been run with SimPEG. So
that's usually a typical inversion.
Yeah, that's pretty cool. That's very cool. Cool. Are there any other questions, last burning thoughts from folks before we wrap up? And or if there's anybody who has stuff that they would like to lead next week, that also would be great to know. No? Okay. Well, we can catch up, and if there's new things that pop up, or if you have ideas during the week of stuff that you'd like to spend some time presenting next week, feel free to just post that on Slack. And from there, have a good afternoon, everyone.
Thanks, Lindsay.
Thanks, Lindsay.
Yeah. Bye, everybody.